I just want to do a couple videos here to prepare you for the quiz on arithmetic and geometric series and the binomial theorem. All right, so here's the first problem. I stole these. These are like typical quiz questions. You might not get these exactly, of course. So here's the sum from n equals 1 to 60 of 3n plus 5. First thing you should notice is that the equation here is linear. That tells me it's arithmetic. It's arithmetic with a common difference of 3, which is always just the slope of that equation. So we go up 3 every time. Of course, you always need to know the first term, which if you plug n equals 1, you get 3 times 1 plus 5. The first term here is 8. And then if we go from 1 to 60, there's 60 terms altogether. That's really all you need to sum up an arithmetic series. I'll write out the formula. Of course, hopefully you have this memorized, but it's n over 2, and then you double the first term plus the common difference times n minus 1. If you remember, there was 2 formulas for this. If you don't know the last term, I guess I've been calling this the alternative formula. Okay, and it's just, you're just plugging in, right? N is 60. If I double the first term, I go 2 times 8. The common difference we said was 3. N minus 1, 60 minus 1 is 59. The whole thing is over 2. And I would jam that in a calculator. And if you add up the first 60 terms, you get 5790. Okay. And number 2 is very similar, except they throw a little wrinkle in here. And if you look at it, they change the index. Usually we start at 1, but if you start at something else, you got to just kind of use your brain a little bit. So again, it's still arithmetic because this guy here is linear, 2n plus 5. The common difference is the slope. It's staring you in the face. It's the coefficient of n. So we go up 2 every time. This time the first term is actually when you plug in 5. Right? Because we start at 5. So the first term is 2 times 5 plus 5, which is 15. And finally, n is a little screwy, right? If we go from 1 to 88, there's 88 terms. From 5 to 88, well, here's the trick, guys. You take the top number minus the bottom number, and you actually got to add 1. I want you to think about that. But from 5 to 88, there's actually 84 numbers. So that seems a little goofy, especially that plus 1, but that's just kind of the way it shakes out. And then, hey, same formula. Man, I'm going to cheat and use my Apple Pencil and copy this as best I can. I guess by the time I did that, I could have just, well, whatever. Okay, so if I plug in here, my n was 84. If I double the first term, that's 2 times 15. Common difference is 2. 84 minus 1 is 83. I divide the whole thing by 2. Again, you could simplify it, but your best bet is to get a graphing calculator. 8232 is what this shakes out as. Okay, that was a couple of arithmetic series. Let's just do one geometric series. Okay. Hey, what's the giveaway that this one is geometric? Number 3. First of all, everything's multiplied. You don't see a plus or minus, and it's exponential. You're raised to the power of n minus 2. If you're exponential, that implies geometric. And of course, geometric has a common ratio, which is just the base of the exponent. So it's 1.1. Okay, the first term is what you get by plugging in 1. So it's 10 times 1.1 to the 1 minus 2. I'd suggest a calculator for that. But I got 9 point, when I first put it in, I got 9.090909, 9.09 repeating. If you change that to a fraction, you could do that on a graphing calculator by hitting the fraction button. It's just 100 over 11. If you want a more exact number. And of course, n is 37, right? If you look at it, that's 37 minus 1 plus 1. So you get 37. All right, here's the formula. Hopefully you've memorized it for a geometric. It's the first term times 1 minus r to the nth over 1 minus r. So the first term is that 9.09 repeating. Again, use either 10, 100 over 11, or put in 9.09090909, carry a bunch of those 09s for accuracy. 1 minus 1.1 to the 37th over 1 minus 1.1. Just be careful when you throw this in your calculator. You better group the bottom together for safety's sake. And when you jam that in, you're going to get just over 3,000. It's 3,000.36. Just be careful on delta math. They'll say on a problem like this, they'll say round to 2 decimal places or round to the 100th place, or they might say round to the 10th. So just be careful with your rounding. Okay, we'll pause here. We'll probably have another video for the rest of the worksheet.